All right, hello, seventh grade. This is Mrs. Flint, and today we're going to start something new. But you did have a little bit of this last year in sixth grade, so some of this will be review and some of it may be new. So first of all, let's just review a few geometric concepts. We talk about dimensions in figures. When we have a one-dimensional figure, that would refer to a line, because a line can only be measured one way, in its length. A two-dimensional figure would be anything that can be measured in two different directions. These are also referred to as plane figures. So if you recognize, this is a rectangle. It has a base and a height, a length and a width, however you want to refer to it. And those are its two dimensions. A triangle, same thing. It's a three-sided polygon, has base and height. This is a pentagon. You can measure its base, you can measure its height. This is a parallelogram. This is a rhombus, and this is a hexagon. And these are all two-dimensional figures, also called plane figures, P-L-A-N-E. So today what we want to start examining are three-dimensional figures. Now when we go to a third dimension, now we add depth. So not only do we have this length and this height, but now we also have the element of depth, which is what makes it three-dimensional. Three-dimensional figures go by a variety of names. We can call them three-dimensional figures. We can also call them solids. Our textbook refers to them as space figures, and really the most accurate geometric term would be polyhedron. So as we're talking, I hope that you are taking notes in your geometry journal. What's really cool about doing this through video is that you have the ability to pause the video so that you can catch up with your note taking and then start the video back up when you're ready. All right, so there's some vocabulary that we're going to want to be familiar with regarding polyhedron. The first is the concept of a prism versus a pyramid. Now, very important distinctions that are true, that give you the difference. There are two things in particular you need to look at, and that would be the number of bases and the shape of the, we'll call them non-base faces. Those are the two things you have to consider in determining whether a polyhedron is a prism or a pyramid. Okay, so let's think about that. I'm going to pause for a second to get some additional materials for you. So I want to show you two different polyhedron and the difference between them. If you look, you see that there are triangle faces and there are rectangular or square faces. But these are two very different figures. And the difference in them is that if we look at this one, you can see there is one square face and 1, 2, 3, 4 triangular faces. The fact that there's only one square face indicates that that is the base of this figure. So it sits on its base. The rest of the faces are triangles, and because of that, this is a pyramid, not a prism. What makes it a pyramid? One base, and the rest of the faces are triangles. Now, we name them more specifically by the shape of the base. This happens to have a square base, so we call this a square pyramid. This, on the other hand, has 1, 2 triangle faces and 1, 2, 3 rectangular faces. So we're going to call the triangles the base, because that's how you could sit this, either here or here. And the fact there are two of them makes it a prism. All the other faces will always be rectangles on a prism. So because the base shape is a triangle, these are called triangular. This is called a triangular prism. So I have some other prisms to take a look at. This one is, if you look at it, you see only squares. Every face is a square. There are 1, 2, 3, 4, 5, 6 faces. That's more commonly known as a cube. It could also be called a square prism by definition. Here's another one that every face is a rectangle, and there are 6 of them. So we would call this a rectangular prism. This one has rectangle faces here. These are called lateral faces. And it also has 2 squares. So the squares would be the base, the 2 bases, and the rectangle faces are the lateral faces. So we would call this a square prism. Here are 2 more prisms. And I know they're prisms because all of these faces are rectangles. And they have 2 bases that are the same shape. In this case, this is a 1, 2, 3, 4, 5, 6 sided polygon. 6-sided polygons are called hexagons. So we would call this a hexagonal base. This is 1, 2, 3, 4, 5, 6, 7, 8-sided polygon, which is called a octagon, excuse me. So we would call this an octagonal prism. Okay, so we know now that the difference between a prism and a pyramid is based on the number of bases and the shape of the non-base faces. So this is an example of a 1, 2, 3, 4, 5-sided base, which is a pentagon. But because all the other faces are triangles, we would call this a pentagonal pyramid. This we could call a square pyramid or a cube. This has a base of a square and other faces, lateral faces that are triangles, so we call this a square pyramid. And this one is a square prism because a triangular prism because the 2 bases are triangles and the other faces are rectangles. Hope that is kind of clear. All right, so here's some more vocabulary. When we talk about the bases, we are talking about basically here, the top and the bottom, which are the same shape. In this case, we only have 1 base when it's a pyramid. And then the lateral faces are all triangles. They are all rectangles on prisms. Now we can also talk about figures that are rounded, that have circles as part of them. In a cylinder, we have 2 bases, just like we do on a prism, but this time the lateral surface is all curved, right, to follow the shape of the circle bases. So a cylinder always has 2 circle bases with a lateral surface, and in a cone, we only have 1 circle base with the lateral surface surrounding it, basically. This point here is called a vertex. Wherever you have things that come to a point, that would be called a vertex. A sphere is like a circle, but 3-dimensional. It has the same concept where you can have a radius from the center of that sphere to any place on the sphere, and it's the same distance from the center. So it is like a circle, but only 3-dimensional. All right, so let's look at what we have. A number on A here, when you look closely, you should be able to see that there are, let me just highlight this for you. There's a triangle base here, and a triangle base on the other side. And because there are two bases, that makes it a prism. And the shape of those bases are triangles, so we call that a triangular prism. On this one, hopefully you can see that there's a trapezoid here and one opposite of it. Those would make them bases, and the other shapes, the other faces are all rectangular, so we would call this a trapezoidal prism. So you can see that the base shape can be any kind of polygon. A has how many bases? Two bases, which makes it, and because they're circles, that makes it a cylinder. This has one base, which is a circle, which makes it a cone. Okay, so now you may remember that there are ways to represent three-dimensional figures in two-dimensional forms, and those are called nets. Nets are patterns that you can use to form a space figure. So you have to envision what these figures would look like when you folded them up. So let's look at, first of all, what do you see when you look at this first one? Well, I see there's triangles. 1, 2, 3, 4, 5, 6 triangles. Those triangles are a clue as to whether or not it's a prism or a pyramid. If you remember, the faces, the lateral faces on a pyramid are always triangular. So this is a pyramid. So now we have to determine what kind of pyramid, and that is based on the shape of the base. And so this face must be the base. And it has 1, 2, 3, 4, 5, 6 straight sides. A six-sided polygon is called a hexagon. So we would call this a hexagonal, I think that's supposed to be an A, pyramid. Okay. On part B here, remembering that bases, there's either one base or two bases, right? And hopefully you can see that there's two triangles here. Two triangle bases would mean this is a triangular pyramid, and all the other faces are rectangles, which is what you need in order to have a pyramid. When you see A here, only triangles. Only triangles. So right away you know that has to be a pyramid because there are no rectangular faces. So then a pyramid only has one base. Everything's a triangle. So this would be a triangular pyramid. And on this one, if you look closely, all you see are squares. That makes that a cube. Okay, so that's it for today. I'm going to give you some practice problems to do, but thanks for listening, and I'll talk to you later. Bye.